Great. So just a quick background on Silver Spring. The nice part is we're actually right next door. So we've been here in Redwood City for about 8 years, and we are a leader in building critical infrastructure networking for smart cities and smart energy applications. So we've been in business, again, over almost 12 years, and we've really driven a number of open standards and open protocols to drive adoption of networking technologies and connecting millions of devices. We have over 22 million devices that have been connected, primarily in smart metering and smart energy applications, but increasingly using that same technology to move into smart city applications. So we've been working with utilities here in Northern California, like Pacific Gas and Electric. If you have a smart meter on your house, that's actually a Silver Spring communications module inside. We're using that same technology to connect and manage new types of smart city infrastructure. So the streetlights in the city of Paris, for example, will be all managed by Silver Spring network technology. Bristol, Copenhagen, Miami, Glasgow, there's a number of Dublin that will all be connected and managed using smart technology from Silver Spring. And I want to talk a little bit about our transition from smart energy networks and smart grids to smart cities. So we think the first thing that's really been core of our technology is building open, large-scale critical network and critical infrastructure networks. So we think the security, the reliability that's been required for energy utilities is going to be increasingly required and common for smart city applications. The ability to shut off the power grid in Northern California is significant, and we've spent a lot of time and effort, and the federal government and utilities have as well, to drive security and reliability standards. And increasingly, that's being transitioned into smart city applications. So if you think about the ability to turn off, manage, control the lighting levels throughout the city of Paris, for example, or Miami, Chicago, those are critical assets that need high levels of reliability, security, and ensure that the technology is functioning. And so we brought that horizontal networking approach into smart grids, and then are increasingly looking at smart city infrastructure networks. So going from tens of millions of devices to hundreds of millions of devices that can be connected, and then opening up that network into IoT applications where literally billions of devices will all be connected, communicating at the edge, and able to send control and command messages between each other. So we've been able to build a really open architecture where you look at the bottom, 125 different ecosystem providers are building technologies, building devices around our products. So that includes smart streetlight controllers, smart meters, EV chargers, traffic signals. The range of devices is really increasing on a daily basis as more and more cities are jumping into smart city infrastructure and smart city applications. And then really what's important is that those devices are able to communicate on that same platform. And so in the case of Miami and Florida Power and Light, the same over 500,000 smart streetlights will be able to be controlled on the same network that is managing the 4.5 million smart meters that are deployed throughout South Florida. What's the ability for these devices to talk to each other and send control messages is also very interesting. And I'll give some examples later on in the presentation around the ability to have a IP camera, for example, that is looking for motion detection and then sending commands to smart streetlights, traffic signals to ensure that bicyclists, pedestrians, as well as vehicles are safe as they move through the cities of the future. One of the interesting trends that we've seen is that more and more cities are looking at their streetlight assets as a really important avenue to be able to make investments in smart city applications. Streetlights are really well positioned. They're high in the air. They're constantly powered. And they have a great business case to be able to add controls. And I'll go into more detail on that. But once that smart street lighting canopy network is in place, the ability to add new devices is just astonishing in how quickly it can move. And so we've been deploying a number of, once we have a smart streetlight network in place, being able to deploy video cameras that measure for security, for surveillance, for motion detection to adjust streetlights is quite easy. We've also integrated with traffic lights and traffic signals, and I'll talk about some of the use cases of what we're doing in Copenhagen and Glasgow. Gas and water meters, these things that are kind of forgotten but have a real cost around efficiency, operational cost of reading those devices, And more importantly, in a situation like the California drought, without having visibility into how much consumption is actually happening at the edge of a network, you don't know how to address it. And so even some of the water shaming that you've seen in SF Chronicle and elsewhere, being able to provide real-time information to a consumer about how much he or she is using allows them to take preventative steps and be able to control consumption. I mentioned that one of the big benefits of smart streetlights is that there's a really positive business case, and we're able to follow on the backs of dramatic cost reductions in LED technology, and also a really solid opportunity to save energy, save operational cost, and then drive new revenue streams through an investment in smart streetlights. First, looking at saving energy, there's more and more examples of using dimming of, these are highly controllable smart streetlights. LEDs have dropped in cost and are now able to save on the order of 50% or more of energy use. Once you add controls, you can actually bump that up to 15 to 25% more energy reduction by using controls. An example is in Glasgow, where they've actually, on all of their high streets, the main streets in the city, they found that the retailers are putting out so much light from their shop fronts that they actually don't need to have very much street light or overhead light at all. So they've reduced their energy costs by 60% on those streets by dimming, because retailers are already providing that energy and they were just wasting energy and wasting cost. On the operational side, there's a huge expense, and I don't know if any of you have ever called your utility, have ever called PG&E or about a streetlight outage, but just driving around, the number of day burners, so streetlights that are on in the middle of the day when they shouldn't be, and the number of streetlights that are off when they should be on is dramatic. And one of our utility customers in Florida, where there's frankly a lot of old people who have time to make the calls and are aggressively monitoring their utility, over 120,000 calls a year come into that utility to address streetlight outages. Proactive maintenance, so there's 15% or more failures at any given point in time in Chicago. So huge numbers of areas are not well lit, they're not well managed, and in many cases they're not even being billed. And so some of our customers have actually found that over 10% of the lights that they've deployed, they're not billing for, and so they're not getting reimbursement for those costs, and the rest of us end up picking that up. So by deploying smart streetlights, they have a better sense of where their assets are and better ability to manage them. And then the last area, and the one that we're most excited about, is the opportunity for cities and utilities to drive new revenue streams and new services. Over half of the streetlights in the US are managed by large energy utilities, and they've been increasingly looking at opportunities to get closer to their citizens and to their municipalities and deliver new services. They're worried about losing revenue streams from solar and other distributed generation, and being able to use existing crews, existing infrastructure, and existing systems to be able to provide a better service is something that they're really excited about. And then on top of that, for cities, the ability to use an existing smart city or smart streetlight network to add in seismic sensors for bridges, noise pollution sensors, air pollution sensors, all connected and all able to communicate at the edge is a really exciting opportunity. When we've looked at this on a per light point basis, there's somewhere between 200 and 400 incremental revenue dollars per year that's available to the city. So huge opportunities for the city to start not only offsetting the cost of streetlights, but even more importantly, turning an asset that used to just be a cost into a revenue generator. And more examples of cities who are thinking progressively about how to change their interaction and how to change the utilization of some of these assets. Cities like San Jose, San Francisco, Chicago have all issued RFPs asking, hey, we've got these assets, come and tell us what we can do with it. How can we make money? How can you help us deliver a better service, a better lighting service, but then also deploy new sensors and new communication models on top of these assets so that citizens have a better experience within our built environment. An example of what this looks like. So this is the suburbs of Chicago, and this is a small streetlight pilot that we've done with ComEd and with the cities of Bensenville and Lombard. It's a little bit hard to see, but the red balloons are smart meters, and the green balloons are streetlights. And what you see is that this is really an example in real life of the convergence of Metcalfe's law and Moore's law. So Moore's law, more and more devices, smart meters, street lights, noise pollution sensors can all be networked and connected. And then Metcalfe's law, where the benefit of a network is proportional to the square of the number of devices on it, or the exponential number of devices on it. And so you just see these meters and streetlights are all communicating to each other. The streetlights have more of the white lines. Those are the connections between devices. And the reason for that is that they're high in the air, they're constantly powered, as opposed to the meters, which may be on a ground level or in the basement. And you can see that there's the real ability for all of these devices to send command and control messages to each other. And that gets exciting when you think about dynamic lighting and dimming, being able to sense an oncoming car and adjusting light levels. We're really excited about having all of these devices increase the reliability, the resiliency, and the redundancy of networks that we're building for cities globally. So we're working with over 500 cities across 16 countries to deploy smart grid and smart city technology. Some of the examples, Florida Power and Light that I mentioned and showed some case studies from, over 500,000 of their streetlights will be connected over the next 2 years. We've recently started our deployment in the city of Paris, where we will manage all of the city's street lighting devices. So 180,000 streetlights will all be connected. They're actually going to maintain the old HPS, or the traditional lights, because they want to keep that very Parisian light quality, the kind of orangey glow and the mysterious glow of Paris, as opposed to the brighter white that's coming from LEDs. And then finally, as an example, the city of Copenhagen, where they're looking to add 20,000 LEDs through some very iconic lighting fixtures, and then are rapidly adding and connecting new devices like traffic management and other applications on top of that same streetlight network. So those are some of the examples of the cities as well as the utilities that we're working with, and more cities are jumping onto streetlights as their first application on their smart city path. And want to talk a little bit about some use cases, some examples of what we've seen that's real in the field today, and cities that are taking advantage of new technologies. You can see here the streetlights, traffic signals, bicycles, water meters, parking kiosks. All of those devices should all be connected on the same open network, giving the city choice as to which manufacturer and which device provider will sell that technology, so that they're not locked into a specific proprietary standard. But then also, by having all of the intelligence at the edge, really allow for a very dynamic and programmable future for cities. One example is Copenhagen. And so some of the work, as I mentioned, we're upgrading all of the 20,000 lights to LEDs. Copenhagen wants to move to they want to be the first 100% renewable or carbon neutral city by 2020. And they've also been really aggressively looking at how they can manage a very different transit environment. Over half of the population in Copenhagen cycles to work. Despite the fact that it's cold, despite the fact that it's rainy and snowy, there's a huge population that bicycles, and what they're looking to do is to ensure that those cyclists are safe and secure and as comfortable as possible as they traverse the city. So what we've done is deploy IP cameras that are monitoring bicycle, pedestrian, and vehicular traffic. And then when a bicyclist comes by, we'll raise light levels and we'll adjust the signal timing so the traffic signals will all go to green, and there's a green wave so that folks can easily move through the city, a lot like San Francisco, and be able to more quickly move throughout the city. An example in Florida. In Florida, there's a number of nesting sites for sea turtles. And when lights are deployed on land, the sea turtles get confused and they'll go the wrong way. And so the baby hatchlings, instead of going out to sea, will actually come on land, and often the PCH, the highway's right there, and so there's a lot of loss of life for the sea turtle community as they go the wrong ways after they're hatched. So what Florida Power and Light, the utility down there, has done is that there's a sea turtle conservancy that will go out and survey each one of the beaches, get down on the sand and look back as to which lights they can see and what would be confusing for the turtles. And then year by year, based on foliage and which buildings at different light levels. They'll tell the utility which lights they should turn off or dim. And that's a huge expense. So it's literally thousands of different truck rolls and different visits to adjust light levels, to dim different devices. And unfortunately, they often get it wrong. So they'll pick the wrong one, or the assets aren't very well marked. So what they're excited about using our technology to do is to have a very clear list that can be done automatically over the air. And then if there's a need and if there's additional surveys, the Conservancy can communicate very closely with FPL, with Florida Power and Light, and be able to adjust the light levels on those street lights so that there's no risk to the turtle population. The last example I'll give is around Glasgow. And Glasgow is a really interesting case in that a lot of the intelligent, bright university students from Glasgow, as well as another partner customer of ours in Bristol, go to London as soon as they graduate. And so there's a huge talent drain from Glasgow to the capital. And what they're excited about is using smart streetlight technology, as well as a number of the open data efforts that were talked about earlier, to allow for mobile development, for new innovation and a new ecosystem to build around using the data to create new applications. And so they're taking information from video cameras around level of service, from noise pollution sensors, from air pollution sensors, from some of the bicycle detection systems that we've deployed, pumping that all into an open data effort and allowing hackers to be able to build new applications for transit maps, for other interesting things that can come off of the network. One example of that is the Glasgow Busyness Index. And so what they've done is they've basically calculated a score for how busy Glasgow is on any given time of day and open that up and make that public for anyone to consume. And what's interesting is that retailers like Boots are taking that and normalizing the foot traffic that they see in their store based on how many people are in the city center at any given point in time. What's also interesting is that events planners, the Merchants Association in Glasgow is using that to gauge the effectiveness of their publicity campaigns and some of the events that they have. And so this is ways of taking a number of different data sources, rolling it up into a single score, and then making it available and seeing how people would be able to use it. More and more, they're looking to get that very granular in terms of traffic levels on particular roads and particular different areas of town, so that you can get more and more precise in the type of normalization and different use cases for the data. So with that, just wanted to thank everyone for the opportunity to talk a little bit about how we've transitioned from being really a smart energy-focused business to much more of a smart city and then an IoT application, and talk about some of the use cases of some very interesting cities doing really cool things on the first step of a smart city journey. If anyone has some questions.
I have a question. You showed a diagram of your IoT edge router being wired into some kind of camera.
Yes.
But how do you connect that IoT edge router to the internet itself? Is that usually Metro Ethernet, or is it wireless, or what do you do?
Sure, so we have a range. The question was, how do we connect our networks to other broadband applications or other networks that the city or third parties may have deployed? We have very flexible approaches. We've worked with the city of Paris, for example. We're tying into the city fiber. In utility networks, we typically work with cellular providers to be able to to open that up into the public internet. In many cases, it's a secure private APN that we've deployed with our utility partners. And then in other cases, we'll work with microwave or other networks that may already be existing. Any other questions? In the back? Great question. So the discussion was, how do you instrument a light? What does connecting a street light look like? So you may be cursed like I am, that every time you drive around now, you'll be looking at each one of the street lights that you go by. But on the top is a photocell. And so it's a photodiode that's typically a dumb photocell. So it has no communication enabled. And based on light levels, then that photocell will tell the light to turn on or turn off. That's a very binary decision, and there's not much configuration or configurability within that device. And they're also prone to failure. So these are basically throwaway devices. They fail about every 3 years. And so with the introduction of LEDs, you're going from a light which also had a lamp that the bulb would burn out every 2 to 3 years. So it made the photocell kind of a disposable asset. You just swap them both out at the same time. to a device that lasts 15 to 20 years that's worth investing in. And so what we've done is include our communications module inside those photocells. So it has both an onboard schedule and a number of programmable devices. It has compute so that you can adjust lighting levels via schedule. And then also it has a failover, if for whatever reason communications were not in place, that it could use the onboard photocell to be able to tell the light to turn on or off. And those twist into streetlights via a standard NEMA socket, which is an ANSI or a NEMA approved device. Any other questions? Great, thank you much.
Thank you.